Many optical systems require multiple lenses chained together in order to achieve the desired effect, and telescopes are one such example. We'll take a look at those and how they work. A telescope is essentially a camera lens plus a magnifying lens strung together. Imagine that a distant object you want to get a magnified picture or image of. A camera can produce a significant magnification, but only in the case when the object is really close by, in other words, close to the focal length. And a magnifying glass works really well if you want to get a magnified image, but then you have to bring the object even closer. You have to bring it inside of a focal length. So how can you significantly magnify a distant object? The answer is actually to combine these two kinds of lenses together. Even though they're both convex lenses, we chain together these two concepts, a camera with a magnifier. Let's see what that means. So let's take a look at taking a camera lens and a magnifying lens, put them one after the other. Imagine I have an object and it's way out, far, far away, well in front of the focal point of the lens. Remember the focal point, if you stand right here at the focal point, then rays come out parallel from the lens. This first lens is generally called the objective lens. And we want to make a real image of this distant object. Rays come off this object and pass through the lens. Those that pass along the central axis here, they will be undiverted. But those that come in either parallel to the lens or through the focal point, we know what they're going to do. The one that comes in parallel to the lens is going to head to a focal point. The ones that heads through the first focal point will actually come out parallel. So these actually all converge. And notice that they have now converged at a point behind the lens, and they've actually really converged. They didn't just appear to converge. So this makes an image, and it's a real image. If I place another lens further down, we'll call this one the eyepiece lens, the one that we're going to look through. This image, number one, actually acts like a light source in front of the eyepiece lens, because now I have a point from which there seems to be a set of rays emanating outward. And when it passes through the second lens, these rays are refracted. If you put the first image inside of the focal length of lens number 2, then that's like saying I'm going to put an object really close to a magnifying lens, and this eyepiece lens acts like a magnifier. So if you're an observer looking into the eyepiece lens, you don't directly see this light source that's in between the two lenses here. You see the image formed by saying that light source made refracted rays, and I extrapolate them back because the light rays I see, I'm not smart enough to know that they refracted. I extrapolate them back until they appear to come from an origin, and I will see a virtual image back here where these light rays appear to intersect. So that image will be also upside down. It's actually not upside down relative to image number 1. It's the same orientation. That means it's a virtual image. And notice that it's not a real image in the sense of these light rays converge over here by me, the observer. They appear to converge. So that's again a sign that that's a virtual image. So a telescope then does all these things in one shot. And you see image number 2, the image that's formed by the second lens. This image number 2 can be magnified quite a bit as long as you bring the magnifying lens up pretty close to the image number 1, and you get its focal point and image number 1 to be pretty much on top of one another. You'll see an image that's upside down relative to the original object, and you'll see it larger than the original object, again, depending on where you place this eyepiece lens. So the objective lens, the first lens through which light passes, is basically there just to form a real image somewhere close by you. It won't be all that big. And that real image now acts as a light source that you can bring your magnifying lens up close to. And that's how a telescope works overall.